Okay, how did you do? Did you find out that the edge length was 3 units? The area of one face would be 9 units squared. And the volume? How many squares would there be in total? 27. 27 units cubed. You're not done. I'll go back. There you go. Okay. So I'll give you some time to write these down. Definition of perfect square. Some more definitions. Square root, perfect cube, and cube root. And I'll see if I can remember that technique for you. Is everybody finished? I refigured out the quick technique for figuring out perfect squares. Do you want to see it? So if you have all your perfect squares up to 25 memorized, so you probably need to work on 13 through 25, but that's not bad. Pick a number between 25 and 50. 31. So if you want to find 31 squared, 31 squared, as far as knowing the numbers between 25 and 50, can you see that it is 6 away from 25 and 19 away from 50? So 31 squared will just be 19 squared plus 6 times 100. If you try that out, 6 times 100 is 600. If you know that 19 squared is 361, then 600 plus 361 is 961. If you check that on your calculator, sure enough, that's 31 squared. That'll work for any number. So if I change, let's do one that you could do. Pick one closer to 50. And not 40 squared, because that's easy, because you could just do 1600. I don't know if we could do a 0.51. Let's just do whole numbers right now. No, you could, but then you don't know the 0.51 here. So then you wouldn't know that. But let's pick something like 47. That seems like a number that would be hard, right? 47 squared. But if you think where 47 is, it's only 3 away here, and it is 22 away here. That means, how hard is it to multiply 22 by 100? Easy. How hard is it to do 3 squared? Easy. 2209. Sure enough, there's 47 squared. So actually the ones closer to 50 are easier because you already know up to 12 squared. So if you wanted to, say, do 43 squared, that's just going to be a 7 here, an 18 here, 1849, 43 squared. Pretty cool. All right, so we've done these definitions. Now we're going to find the square root of 1,296 without a calculator. The square root of 1296 without your calculator. And if you don't have this one memorized, the best way to do is to make your prime factors. 1296 can be divided by 2. That will leave you with 648. That can be divided by 2, leaving you with 324, which can be divided by 2, which leaves you with 162, which can be divided by 2, which leaves you with 81, can be divided by 3, 27 can be divided by 3, 9 can be divided by 3, 3 can be divided by 3, and finally we get 1. So 1296 is equal to, and we could write out 2 to the 4 and 3 to the 4. What I'm going to do is I'm going to put 2 sets of brackets here. Because if I want it to be a perfect square and I want to figure out the square root, I need something times itself to equal 1296. So if I put a 2 in here, I need to put a 2 in there, and that will get rid of those 2 factors. I'm going to put another 2 in here and another 2 in here. Now I've used up all my 2's. That's the same as 2 to the 4, but I just put it in 2 different brackets. Can you see that you can also put 2 3's in the first one, 2 3's in the second one? That will use up all of my 3's. I've split it up into 2 equal groupings because what are these numbers equal to? 2 times 2 is 4, times 3 is 12, times 3 is 36. So the square root of 1296 is 36. So that's a method how you could do it without your calculator. The more efficient way is to use your calculator. Okay? Now, this technique that I was just like saying, could I use this technique where I figure out how many are different, the difference in between them, to figure this out? And I thought about it and I said, well, there's always something times 100, right, in my technique. If I did 12 times 100, there would be 96 left over. Is that one of the perfect squares you know? No. 96 isn't a perfect square. If I did 11 times 100, that's 1100. That would leave me with 196 left over, which, if you have them memorized up to 25, is 14 squared. And 11 and 14 add up to the 25 for our technique. So I would know that 11 would be the one number and 14 would be the other number. And if you get used to the technique, 25 plus 11 is 36, and it works. But you have to get used to that technique, so you have to watch it and practice it a little bit. You shouldn't, watching that, you shouldn't be able to understand that yet. That takes some time to practice, to see, play with numbers. But that's fun. I love playing with numbers. Okay, another example. Find the cube root without a calculator. All right, let's see how you did. 1728 divided by 2 gives you, what does that make? 864 divides by 2, 432 divides by 2, 216. And if you're finding a cube root, it kind of gives you a hint. If you can divide by 2 once, you're going to have to be able to divide at least 2 more times to make a group of 3. So now that I can divide by 2 again, which gives me 108, divide by 2 again, 54, divide by 2 again, 27. Divide by 3, 9, divide by 3, 3, divide by 3, 1. So 1728 equals 3 equal groups if we want to find a cube root. There's 6 2's, so there would be 2 2's in each group. There's 3 3's, so there'll be 1 3 in each group. And we have 2, 4, 12 times 12 times 12. (1728) reminds me of a story about the number 1729. 1729, there was a mathematician, an undiscovered mathematician. This was in about, I don't know my dates. I know some of the characters. I don't know my dates. But maybe 50, 100 years ago, there was a mathematician that was discovered in India. He lived in a small village, and he had no formal schooling. But when they found him, he was doing high mathematics that no one had ever taught him. He just played with numbers and figured things out. And so because of this, mathematicians in Europe said we gotta fly him to a university. They flew him to a university in London. He met a mathematician named Hardy, and he arrived at Hardy's house, and the first time they met, he arrived in a taxi, and the taxi's number was 1729. And being math people, Hardy said to this Indian mathematician, which I can't pronounce his name, I can't remember it right now, but he said to him, it's too bad that our first meeting had to deal with a number such as 1729, which has little or no, like it's not that exciting of a number. And the Indian mathematician said, on the contrary, it's one of the first numbers that can be represented as two distinct sums of cubes. 12 cubed, which we just figured out is 1728, plus 1 cubed makes 1729. And 1729 is also 10 cubed plus 9 cubed. And that was their first meeting of these two mathematicians, and then they went on and did a bunch of math and had lots of fun. Those kind of things. You know, what you'd like to do in your spare time, but you don't have time. So now we can get into questions with algebra. You have a square, and the area is 144 x squared y to the 6. We need to find the side lengths of this. Of course, those side lengths will be the same. If you just had 144, what would the side lengths be? 12 and 12. So we know that there's going to have to be a 12 here and a 12 here. Now what times what is x squared? X. So we know there has to be an x and an x, an x, and an x. Now is it possible to get y to the 6? Because 6 isn't a perfect square. Yes or no? What times what is y to the 6? Just going to see if you can remember all your exponent rules. Y cubed and y cubed. Right? Because what is your exponent rules for multiplying? What do you do with it? You add the exponents. So even though 6 isn't a perfect square, with exponents it's okay. Because y cubed times y cubed would be y to the 6. So side length is 12xy cubed. Try this one with a perfect cube. How are you guys at drawing cubes? Draw a square, then go off in 3 dimensions. All the sides are going to be the same. One side here, one side here, one side there, the height. And to figure out the volume, it's going to be 3 things that are identical. So we would have 125 x to the 9 y cubed equals 1 set of brackets, 2 set of brackets, 3 sets of brackets. So what times what times what is 125? 5. So we know all of these will have a 5 in them. To get x to the 9, how would that be broken up evenly between the 3? X cubed here, another x cubed there, another x cubed there. Again, multiplying is where you add the exponents, so that adds up to 9. And to get 3 y's, we would need 1 y here, 1 y here, 1 y here. The last question that we're going to do, we're going to use our calculator. We have a volume of a cube. It's 4913. We need to figure out what the surface area is. And I'll draw. Question is asking for the surface area. So let's just start off with the idea. What do I need for the surface area? Length times width will give me one of the squares, right? How many squares will there be in a surface area? Right? There's going to be 3 here and 3 on the back, so 6 squares. And those 6 squares are going to be length times width, but does it make sense that all of these sides are going to be the same? So the area of one square will be x times x, which is x squared. So this is what I need to figure out the surface area. Now that I've decided what I need, how does the information that I'm given, which is the volume is 4913, how can that help me? Can that help me find x? So my volume is 4913. How does that help me find x? So if we look at our formulas, volume formula for a cube would be length times width times height, right? So my volume here, length times width times height, is the same as x cubed on this side. And on the left side for the volume, what can I write? Well, I know the volume is 4913. Now, the reason we're going to do this one with our calculator, if you tried to do it with the line, you'd have to try to divide by 2. It wouldn't work. Try to divide by 3. Doesn't divide by 3. Doesn't divide by 5. Doesn't divide by 7. Doesn't divide by 11. Doesn't divide by 13. And those are already big numbers. If you go to your calculator, do the cube roots. So let's find on our calculator, how do we do cube roots? Okay, 2 different ways. The easiest way is if you can't find anything on here that you like, because we have a square root, but we don't have a cube root, hit the math button. And you can see number 4 is a cube root. What's the math button? The math button is right below your colored button. There's your cube root. Type in 4913 and push enter. And it tells us it's 17. And so now we can go back here and say, once we've taken the cube root of both sides, that x is 17. So now we can figure out our surface area. It's going to be 6 times 17 squared. And that's going to be a big number. 6 times 1734. What units were we using? So this is surface area, so now this will be inches squared. And there's the homework.